Okay, we're going to continue um, with last time from 3.6, and we ended with this equation, this function to graph. Um, and so we wanted to find the x and y intercepts. We wanted to find the domain and range, and we also wanted to find the horizontal and vertical asymptotes. Well, maybe in the other order. But these are the things that we wanted to find, and we noted that this is just a shift. This is just a shift of the function g of x, which is 1 over x minus 1. So let's do number one part here. The first part, x and y intercepts first. So let's find the x-intercept. That's when y equals 0. So we said 0 equals to 1 over x minus 1 plus 2. So negative 2 is equal to 1 over x minus 1. So negative 2 times x minus 1 is equal to 1. Negative 2x plus 2 is equal to 1. So negative 2x is equal to minus 1. And so x is equal to 1 half. Okay? So at x equals 1 half, y is equal to 0. That's our x-intercept. For the y-intercept, let's just do that right next to it. For the y-intercept, we set x to be 0. So y is equal to 1 over 0 minus 1 plus 2. So y is negative 1 plus 2, which is 1. So when y is 1, x is 0. And so we have these points which we will label on the graph when we do the graph. Okay? Well, we know that this is just, two things we know. One is that if we look at the original function here, h of x being 1 over x minus 1 plus 2, we still are not allowed to be equal to 1. So our vertical asymptote is always the place, this is the place where the denominator is actually equal to 0. So in this case, our vertical asymptote is the line x equals 1, just as before. However, the horizontal asymptote changes. And why does it change? It's because the horizontal asymptote has to get lifted by 2 units. This gets lifted by 2 units in comparison to g of x equals 1 over x minus 1. Now, before I do that, I just want to state one thing about the previous horizontal asymptotes. Let me put this in as a little side box here. Note that g of x was 1 over x minus 1. Now, what you could do to find the horizontal asymptote here is just think of x kind of going to plus or minus infinity. If x is becoming a really, really large number, like 1,000,000. So for example, if I plugged in x equals, 1,000,000 here, what would I get? I would get 1 over 999,999, which is a very small number. It's close to 0. This is close to 0. So if you have just a constant number like 1 divided by something that's sort of going to infinity, I'm just going to put that in quotes, then this thing essentially goes to 0. So it gets closer and closer to 0. In a similar way, if we think of h of x, now let me come back to my usual script here, h of x as 1 over x minus 1 plus 2, and we sort of send x off to plus or minus infinity, well, what happens? You get 1 over something that's basically infinite, which is really small. This thing is like 0. And then we add 2 to it, so this actually equals 2. And this is sort of the procedure for finding the horizontal asymptote. If you send x to infinity, what happens to your function? If x is really, really large, so let me summarize here. So when x is very large, okay, both either negatively or positively, meaning going towards plus or minus infinity, then h of x, it still equals 1 over x minus 1 plus 2, but this part that I've circled, this is almost, and the keyword almost is correct, it's almost 0. So you tend towards going to the line y equals 2. You're almost at 2. You're never actually at 2, but you're almost at 2. So that's how you derive algebraically that the horizontal asymptote is 2. So let me summarize what we have so far. So we started off with h of x being 1 over x minus 1 plus 2. We solved for the x-intercept, and we saw that that was x equals 1/2, and that's where y is 0. We found our y-intercept. When we set x to be 0, we got y to be 1. Our vertical asymptote was where the denominator was 0, aka x equals 1. And our horizontal asymptote is when we send x to plus or minus infinity, the y values go towards 2. So our horizontal asymptote is y equals 2. And this gives us enough information to graph this with a relatively good amount of detail. So here's 1, and here is our vertical asymptote. And our horizontal asymptote is at y equals 2. So 1, 2. Here is our horizontal. So for the horizontal asymptote, it's always good to draw some dotted lines here. And we have 2 points that we already know. One is the point, the x-intercept, which is a half comma 0. Let me put the points in red here. So a half is here. This is a half comma 0, and then there's 0, 1. So you're going to get this piece of the graph right there. And just to get at least one more point, let me plug in, say, x equals, so if x equals 3, or 2 even, let's just put 2, then y equals, you can compute that equals 3. So we have 2 and then 3 here somewhere. And so the graph on the other side would be like so. Okay. All right. This is the graph of this function. Now, I want to just do one last thing, which is the domain and the range, and maybe state one additional comment about this function. So the domain here, we already saw that x can't be 1. So we have a negative infinity to 1 as well as 1 to positive infinity. And then the range, what is the range here? Notice that every line crosses the graph except the one at the horizontal asymptote. So the horizontal asymptote is the only one missed. So the range here is negative infinity up to 2, as well as 2 to positive infinity. Essentially, you remove the horizontal asymptote, which in this case was y equals 2. And that is your range. Okay, so that answers the questions that we asked. Let me leave you here with a couple of things to think about. Note here that I could have actually combined this into a single expression. So let's actually combine this to make a single algebraic expression. So this is 1 over x minus 1 plus, and I'm going to multiply here the top and the bottom by x minus 1 so that I get a common denominator. So this is 1 over x minus 1 plus 2x minus 2 over x minus 1. This is actually 2x minus 1 over x minus 1 when we combine the numerator terms. So h of x can also be written in this way. And a lot of problems, what they do is they start you off in this way, and you can do everything we did using this form of the function. So what I'm going to do as my last example here for this section is to do a problem that's entirely in this form. So this is a new problem. let's call this f of x. So let's say f of x is 2x plus 4 over x plus 2. So we have a new function here that is not, at least it's not written in the form of just shifting. It's just written as is. And what we're going to do is we're going to try to solve this directly and then see eventually that this is actually a shift of some other graph. So let's do this directly. So what do we want to do? We want to compute x and y intercepts. We want to compute the vertical asymptote and horizontal asymptotes. And we want to compute the domain and range. And then we want a graph. So we'll do this for this example, and then we'll conclude here. So for the x and y intercept, let's set x to be 0 for our y-intercept. If we set x to be 0, we get y equals 4 over 2, which is 2. So we have 0, 2. For our x-intercept, we set y to be 0. So we get 2x plus 4 over x plus 2 is equal to 0. Let's actually, you know what? Sorry about this. Let me change x plus 2. This is a slight technicality here. Let me change this to x plus 1 so that this is actually 4 divided by 1 here, which is 4. And so you get the point here, first of all, 0, 4. Apologies for that. I just want to make sure that a weird abnormality does not occur. So redoing here, we have 2x plus 4 over x plus 1. Our y-intercept, we set x to be 0. We get y equals 4. For our x-intercept, we set y to be 0. And we get 2x plus 4 over x plus 1 being 0. We multiply both sides by x plus 1, or cross multiply the x plus 1, you simply get 2x plus 4 being 0. And so 2x is equal to minus 4, x is equal to minus 2. So this is our x-intercept, the point -2, 0. And so now we want to move to the domain and the range. Or sorry, we want to do the vertical asymptote and horizontal asymptote. The vertical asymptote, so let me rewrite the function here. The vertical asymptote is where the denominator is 0. So VA is where the denominator is 0, so x plus 1 is 0 means x equals minus 1. So we have our vertical asymptote. How do we do our horizontal asymptote? This is the question that is a little bit different now because we don't have shifts. So we have two methods here. I'll call this method 1. And then we'll do method 2, which is going to be converting this to a shift using long division. So method 1, okay, what happens? So the question is, what happens as x goes to plus or minus infinity? So what I'm going to do here, I'm going to take 2x plus 4 and x plus 1, and I'm going to divide the top, I'm going to multiply the top and the bottom by 1 over x. And you'll see why that's important. So if I multiply the top and the bottom by 1 over x, what happens? Well, 2x times 1 over x, that gives me 2. 4 times 1 over x, that gives me 4 divided by x. That's the numerator. The bottom, x times 1 over x gives me 1. 1 times 1 over x gives me 1 over x. And so now when x is getting really, really large, this piece is becoming smaller and smaller. 4 over x, when x is like 1,000,000, that's a really small number. In a similar way, when x is really large, 1 over x is a really, really small number. It's like 0. So this thing tends to go towards the number 2 plus 0 divided by 1 plus 0, which is 2 over 1, which is 2. And so the horizontal asymptote, these are all the y values, it turns out that y is equal to 2 is your horizontal asymptote. Okay, so let me just reiterate one more time because this is a new method. I multiply the top and the bottom by 1 over x. And for these types of problems, this always is going to work. Where you have a degree 1 polynomial over a degree 1 polynomial, you can always do this method, multiplying by 1 over x. And when you do that, you can see that these two red pieces, those go to 0. And so what you end up with is just 2 over 1, which is 2. And that's your horizontal asymptote. I recommend this method for these types of problems. Method 2 is also just as effective, but I feel like it's a bit more work. This is to use long division. And this, I would say, what I'm going to do is I'm going to do this at the end. If you want to see it as, if you want to make f of x look like one of the previous examples, you'd have to do this. And I will put a little star here that we're going to do that at the end after we finish up the rest of this problem. So we got our vertical asymptote, our horizontal asymptote, x and y intercepts. We can actually graph the function now. So let's plug in vertical asymptote is at -1 here. So -1, we have dotted line. We have our horizontal asymptote at 2. And we have our x and y intercepts here. So we have the point 0, 4 and the point -2, 0. So 0, 4 is right here. Let me draw the points in red. And then -2, 0. And those points help us to actually graph this, the function, because now notice that, remember, as x goes to -infinity, the graph must get closer and closer to the horizontal asymptote. As x gets closer and closer to -1, I must go to -infinity here. On the other hand, on the right side of this vertical asymptote, as x goes to +infinity, I must get closer and closer to the horizontal asymptote. And as x grows up to, x goes to -1, so let me write these things down. Right here, if you kind of look at this region, this is where x is going to -1 from the right. And when that happens, y goes to +infinity. Over here, x is going to -1 from the left, and there, y is going to -infinity. That's exactly what should happen, or that type of event should happen when you get near a vertical asymptote. On the other hand, down here at the edges, when x is going to +infinity, y should get closer and closer to 2, which is our horizontal asymptote. Similarly, when x goes to -infinity, y should get closer and closer to 2. So that's exactly what's happening, and we can read off our domain and range visually. So the domain is just, well, it's everything but the denominator being 0, or everything except the vertical asymptotes. So -infinity to -1, union -1 to +infinity. The range here is, well, notice that every y value gets attained except the horizontal asymptote, just like before. So it's all x, all, let me erase this. This is all x except, all y except the horizontal asymptote, which is y equals 2. So you get -infinity to 2 union 2 to +infinity. Okay. Okay, so that's this example. I will just mention the method 2 here, which you, depending on what your strengths are, you can decide to use or not. Our function was f of x being 2x plus 4 over x plus 1, and what we do here is long division. Okay. So 2x plus 4, you can do synthetic, I guess, if you'd like to, but if you do long division, you'll get the following. This goes in twice, you get 2x plus 2. Subtract, you get a remainder of 2 here. So 2x plus 4 is equal to 2 times x plus 1 plus the remainder 2. This is what you get using the division algorithm. We substitute this part in the numerator, this little underlined part. So f of x is equal to 2 times quantity x plus 1 divided by x plus 1. And in the numerator, you have a plus 2 here. And so what happens is you can split this into two fractions. This equals 2 times x plus 1 over x plus 1 plus 2 over x plus 1. And so now you have, since these cancel, you get 2 plus 2 over x plus 1. And now you can see that this is actually a shift of a graph. You could, think of it as 2 over x being shifted to 2 over x plus 1 unit to the left, and then bumped up by 2 units to get your final f of x. So this is how you would see the horizontal asymptote being 2 here. Notice now that as x goes to infinity, the y values go towards the number 2, because this piece will go to 0. So this is the other method to compute the horizontal asymptote. It's not a bad method. I feel like it's a little longer than the other one, but it's also a good one if you like the division. Let's stop here. I'll leave you here with a little exercise, one last exercise, and we'll start with this and then go into 3.7 in the next video. So let's say f of x is equal to negative x plus 1 over 2x plus 4. And so go ahead and do the same things. We want to find the x and y intercepts. We want to find the vertical asymptotes and horizontal asymptotes. And we want to find the domain and range, and then the graph. So we'll start with this one in the next video and then go into 3.7.